Okay.
Okay, so we are live. Hello, everyone. Hello, virtual Java user group attendees to our first April session. I will be your host today. My name is Ivan. And before we start, let me tell you more about our Java user group. So we are the virtual Java user group, a Java user group that hosts and has more than 17,000 users. And we are virtual since day one. We are happy to have Snike as sponsors. And if you don't know about Snike yet, Snike creates developer tooling that enables developers to scan their projects for known vulnerabilities in their open source dependencies. Okay, I got it this time. Yeah, and if you want to join us, you can go to the virtual Jug Slack, and there is a channel there called Live Session. And in this channel, you can ask your questions about the session today. Of course, you can provide your feedback to the virtual Jug Twitter handle or to my Twitter handle, which is Ivan_Stefanov. And without further ado, let's see what we have today. Today, we are going to discuss front ends for web, mobile, and desktop, and how should Java developers build them. And our guest today is a first timer in the virtual Jug. It's Karsten. Welcome, Karsten. Welcome to the virtual Jug. Good to have you here. Hello?
Yeah, I'm here. Can you hear me?
Yes, we can
Wonderful.
hear you. Good to have you here. Can you say a little bit about you?
Yeah, sure. I'm a Java developer. I've been developing in Java for 22 years, worked in a couple of places in Europe and the United States. I have worked in my own startup there for 13 years in the States, and then I came back to Germany with my wife. I recently moved to Milton Keynes and couldn't help but join another startup last year. So we're about to launch this summer. And in that startup, I'm working on web and mobile client, and that's the origin of this talk today.
Okay, awesome. Then I think that the stage is yours. You can share your screen if you want.
Okay, so I'm sharing my screen, and you should see the Hello VJUG slide.
Yeah.
Wonderful. Okay. And now I'm about to go full screen with my presentation. And then once the presentation is on, I can just see the chat and hear you guys. So yeah, can you see my title screen?
We can see your title screen.
Okay,
and
wonderful.
To our viewers, let me tell our viewers that they can ask their questions in the live channel, in the live session channel in our virtual Jug Slack. And I will be happy to relay them to Karsten. He asked me to do this at the end. So it will be a 40-45 minutes talk. And at the end, you'll get the chance to ask your questions, or actually, I will ask your questions. So yeah, Karsten, the stage is yours.
Wonderful. Okay, thank you. So today I want to talk to you about how Java developers should build front ends for web, mobile, and desktop today. So if you want to find the slides and the video, if you want to get additional information on my talk, if you want to give me feedback on how I did and how I can do better next time, if you want to get started yourself with code, writing code, I've got lots of links, and I also have a newsletter. So for all of that, you can either just type in this link, bpf.li/buyer, or you take out your smartphone and take a QR code screenshot here. The link is also in the talk abstract, so you find it on the meetup page. And I'll show this slide again at the end. That's why I'm moving on in 3, 2, 1, 0 seconds. So what are we going to be talking about today? It's actually 5 points. The first one is, what options do we actually have to build front ends today? The second thing, since we are Java developers, what do we actually wish for? What is it, close to our heart as Java developers specifically? And then I'll be talking about 3 different common scenarios. The first one is we build a new web application from scratch. The second is we're going to supplement that web application with new native iOS and Android apps. And the last scenario is we already have a web application. So what are we going to do on the desktop? Now I'm about to give advice, and it's always good to ask, what's my angle? Am I trying to sell you something? Am I associated with any of these projects here? So as I already mentioned, I've been a Java developer for 22 years. And this summer, I'm about to put my 3rd full stack web developer project into production since 2018, actually. Now, don't fret, this is not one of these, I tried something in my project once, it worked, and now you all should do the same kind of talks. Instead, I'll give you 12 criteria with which I measure these solutions that are presented to you, these frameworks that I'll be talking about, and then you can take these criteria, you can weigh them differently, or maybe even come to different conclusion. But it's a lot of facts. Yes, my experience plays into it, but I spend a lot of time trying to create analysis to supplement my personal project experience. I'm not associated with any of these projects. I'm not trying to sell you a training course or book or something. All I'm doing here is I'm giving you options. And what you need to do is you need to decide, right? You can take my criteria, you can twist them, you can change them, you can weigh them differently. In the end, it's got to be your criteria. You got to evaluations in your environment, and you got to make your own decision in the end. So in short, please don't sue me if your project fails after you took on my advice. So back to our first point on the agenda. How can we actually build front ends today? First of all, we got to talk about, what kind of applications or what kind of devices are we targeting? So we're Java developers. It's no surprise we're building enterprise application. And that's what this talk is about. So it's forms, data grids, reports, think expense, expense applications, something along those lines. I'm not talking about games or media players. There are separate frameworks and tools just for that. It's just a run-of-the-mill enterprise application that you all use day in, day out. And in the enterprise, of course, there's 2 kind of classes of devices. There's the PC, still going strong, Windows, Mac, and Linux, but mobile eats into that. iOS and Android, become more and more dominant. They already, dominate the consumers, but in enterprise, they're slowly marching up there. So how can we actually build for PC and mobile? I think the first option I'd like to explore is to go safe. So I want to pick something that I know is still going to be here in 5 years. And there's 2 safe options here. The first one is the web. We build one application and it runs everywhere. Wonderful. On the other hand, the other extreme is this. So we're building a native application. Well, not one, actually 5 native applications. So those are the 2 safe ways of which we're certain they're still going to be here 5 years from now, and that's why we could choose them today. So how do they compare? Well, with web, we have 1 code base, and we like that. With native, we actually have 5 different code bases, right? And that's not good. Now, the web generally is a bit slower, but native, gives us the full speed of the underlying platforms. With web, we have less features, especially on mobile. Love it or hate it, but iOS, gives you a somewhat crippled browser. You don't have push notifications. You've got less or no background work. And even across all browsers on mobile, you've got restrictions. So for instance, you can only store maybe about 50 megabytes. So if you, like I do, develop an application where you want to store hundreds of megabytes locally for offline use, then you can't use the web. But you can pretty much do everything with a native application. With web, we have JavaScript, and as Java developers, we don't like JavaScript. It's not a really good language, at least not to us. We love our Java. But on native, it's actually worse. Now we have 5 different languages, and none of them is Java. That sucks. And the last thing is debugging. It's difficult on the web. Try to step through your code line by line. If it runs on a mobile phone that's connected to your computer, that's difficult. But native, you've got easy debugging experience. So now if you look at this comparison, you may get the idea, can't we just combine the best of both worlds? And yes, there's a promise of doing that, which is cross-platform. Of course, you got to be a bit skeptical with these kind of claims, and we'll investigate this in detail here during the talk. So what kind of web frameworks have I picked for this talk? 6. The alphabetical order, Angular from Google, appeared in 2016, at least the modern version, not AngularJS, that's older, but Angular 2, now just Angular. JSF is actually the oldie. Now it's called Jakarta EE. It first appeared in 2004. React is backed by Facebook, came out in 2013. ThymeLeaf is a templating option, but it's popular in the Spring world because it's default with a Spring MVC. It's about 10 years old. Vaadin from the company of the same name is more than just a web framework, but I've given this talk a couple of times, and pretty much every time people ask me about Vaadin. So Vaadin. I think it's a Finnish company, if I'm not mistaken. Vaadin is in this talk. And the last is Vue.js from 2014. For cross-platform, I picked 4, again in alphabetical order. Flutter from Google, the youngest one here on record from 2018, just 2.5 years old. JavaFX, originally with Sun, then Oracle, and now ending up with a company called Gluon. I think it's a Dutch one. React Native, also from Facebook, the little brother or little sister of React, came out 2 years after React, the web version. And then Xamarin, the modern incarnation from about 2011, started out with a different company and now belongs to Microsoft. I'm not going to be talking about native frameworks here today, pure frameworks here, like the iOS or Android or Windows SDKs. And the reason is, I think they've got a bad price-performance ratio because you build different clients, and in the end, I think either with web or cross-platform, you can get a better bang for the buck. So no native frameworks today. But before we go on and talk about the web frameworks, I just want to establish the state of the art. And I believe the state of the art to be declarative. So what does that mean? I'm going to give you an example of how to build a declarative user interface with Apple Swift UI. So here we've got an application. It's about as simple as can be. We've got a counter and we've got a button. And hopefully, if we press the button, the counter does increase. So we see here our state variable in the top of the slide, counter set to 0. And then we've got a label that references that counter, with that backslash syntax. Then we've got a button underneath on the right-hand side. You see the code on the left hand. You can already guess, yes, it's going to increase that counter. And it also has a text label. So let's get rolling. So we push that button. And now the event handler fires. The state gets increased from 0 to, yes, you guessed it, 1. And now what happens, and that's a bit unusual, at least in some frameworks, the UI, the framework takes over, Swift UI in this case, and it updates the UI. So it's not our button that says, hey, text label update. It's the framework that redraws itself. And it realizes the only thing that's changed really is that text label, because it references that counter, that state that we just changed. And as a result, the UI updates, and we now have a 1 on the screen. Marvelous. So what did we just see? What was that? Well, I think we actually saw 3 things that are emblematic of these declarative UIs. The first thing is, we just saw code. We saw the labels, we saw the state, the behavior, everything, even, attributes like the alignment of something, all written in code. So there's no UI builders anymore. Visual Studio and JavaFX, Apple with their interface builder, they all had UI tools, where you dragged and dropped stuff. And now that's not really happening anymore. Instead, we just write our code, neatly indented, but our entire UI is code. And because that is the case, we can just click it and save it and run it. And you see an example of that later on. So UI is code. That's the first thing. The second thing is, we have the status as part of the component. Here we've got a very simple component with just a simple counter, but then we've got an event that triggers and updates the status. Nothing earth-shattering. We had status and events in the past, but here they're part of the component. The component knows about the state. And then finally, the framework drives the update. So it's not our code that updates the button, it's the framework that does it. All we can do is indirectly update the button at the label, by updating the state, and then the framework drives the update. So declarative means we build our UI as code. The components that we build have status and events built in, and our framework drives the updates. Now, why do I say it's state of the art? Who's actually using that? Well, you've seen Apple Swift UI, so it's been out for nearly 2 years on macOS and on iOS. React Native works the same way. It's on iOS and Android. React on the web has worked like that, for ages. Then we have a tool called Jetpack Compose. It's the Android Swift UI, and if you want to express it swiftly. And it's to come out in 2021, make it into production. It entered beta earlier this year. And of course, Microsoft can't be far away. They have a tool called .NET Multi-Platform App UI in November 2021. That's also going to be a declarative tool. It's not just going to be declarative, but it'll have a declarative option. So if we now step back and see, what's the state of declarative in these platforms, we see that it's already recommended to build declaratively on iOS and macOS. It will be the recommended way to do so on Android later this year. And on Windows, we will have it as an option also later this year. And that's why I'm saying, the state of the art for front-end development for UI building is declarative. Why am I hopping on about the state of the art? It's really 2 reasons. The first one is, whatever framework you pick, chances are that it doesn't work out, and that you switch frameworks, change framework. Maybe you go down, you start using Flutter or React Native, and it doesn't work out. Then you switch to native, iOS and Android. You can't take your code with you, but you can take your knowledge and your approach because they're all declarative, right? So your boss is happy. And of course, it also increases job security. If you know declarative, then you can build more easily with all these frameworks. It's easier for you to get a new job. So, you're happy. So let me sum up front ends for you. We want to build enterprise applications on PC and mobile. We have 6 frameworks for web that we're going to look at. We've got 2 cross-platform, 4 cross-platform frameworks, and the state of the art are declarative front ends. And so we can check off the first agenda item. And now, what is it that we Java developers wish for? Well, here's the 12 criteria that I referenced at the beginning. So first, we'd like to write our front ends with Java. We want to be declarative because we just saw it's the state of the art. We want to pick a safe option, something that we know is going to be there 5 years from now. We want to pick something that's popular. I'll be explaining that in a second. We want to build web, mobile, and desktop. We want to have something that gives us extensions, no plugins, libraries, frameworks, whatever you want to call it. We want to use somebody else's code and save time. We want to get fast front ends. We want to have access to all the native functionality, where available. We want to just have one code base. And we want to have a fast build, deploy, and debug cycle, because that's really a time suck. If that's taken a long time, it can be the end of you. So why am I talking about popular? What is it? Why do we care about whether technology is popular? Well, it's really 4 reasons. The first one, if you pick a popular technology, it's easier to learn. You find more books, more training courses, more videos on YouTube. Build, deploy, and debug is also easier because you just find more tools, and the tools that are out there are more mature and more capable. And if you're a boss or you have to convince your teammates, it's also easier to find developers for popular technologies. And then finally, if you develop with technology X and everybody tells you that technology Y wins, your life is just going to be so much harder. You'll be swimming upstream. So you rather develop with technology Y, the one that everybody tells you is winning. Now, I find it actually hard to define, what is popular. And that's why instead of just, reading the tea leaves, I went about measuring things. And I measure 6 data points. And you'll be seeing that in a few minutes. But if you have any suggestions for improvements, any other ways to measure popularity, please let me know. So these are our 12 criteria. This is our Java wish list. And so now we start by looking at web application. As a reminder, those are the 6 frameworks we're talking about. So let's investigate what's popular. The first one is, I just did a Google search. I investigated what are people searching for. So it's trends, you see that here in a second. And trends favor new technologies, because if you don't know a new technology, then you're going to Google it. So here are search trends for the last 9 years. The first lines, you just can barely see them. They just hover above the 0 line, are Vaadin. Thymeleaf is not on there, but it would look the same, just barely register the green lines. The red line is Java server faces, was somewhat popular, 10 years ago, but declining and just not measurable in search volume anymore. The latest framework, the youngest one, Vue.js, became popular, but then plateaued and declined a bit over the last year. Angular used to be the most popular one, but has been declining for about 3 years. And React is the most searched for, but it's also declining as the other frameworks. And I'm not sure why they're all declining here at the end. Maybe that something to do with COVID or so, but they all decline, but relatively speaking, React leads, in front of Angular and then Vue. Next one, Stack Overflow. So the percentage of questions on Stack Overflow, you can find that out. So you can, of course, say, well, is that good or bad? If lots of people have questions about the framework, maybe it's buggy, maybe it's purely documented, maybe it's just hard to understand. And I decided lots of questions are a good sign. So here we go. This is from 2009 until today. Vaadin just barely registers at the bottom of the chart. Same is true for Thymeleaf. First one that makes a bit of a dent is Java server faces, but declining for the last 7 years. Vue.js made a bit of a splash, but plateaued about last year. Angular, similar to what we saw on Google, declined since 2018. And here, the big difference, React growing. So it's about 5%, so 1 in 20 questions on Stack Overflow these days is about React. Next one is Udemy. They sell online courses. So I looked at the courses and the students that are attending. Again, is that a good or a bad thing? And I decided it's a good thing. So here we see, React leading. Angular has about, 2/3 of what React has, and Vue has about 1/3 of the courses of Angular, of React, I'm sorry, and the rest just barely registers. Now, when we look at the students, the number actually people participating, then Angular is a lot closer to React. Vue still at pretty much 1/3 of what React is. Next, I looked at the books at Amazon. I just looked at the books that are sold in the United States. In the technology, computer and technology category, and English box. Again, you could ask whether it's good or bad. I decided it's good if you have many books. And you can find the links for all of these things and detailed explanation on my talk page, the one that I gave you the link to at the beginning, at the end, and you can do the searches yourself. So here we go. Angular leads in books, React just closely behind, Vue a distant third, and the rest don't really exist. Next one, I looked at jobs at Stack Overflow. And there you can, many people don't know, you can post jobs at Stack Overflow, but there you can search for jobs. And the interesting thing is you can use the same labels as you can when you search for questions. So, you can search for React Native or Vue.js. Technology can be, or multiple technologies can be mentioned. So it's not whether you get a job, if that's a result, so whether that technology is mentioned. So you often find, like Xamarin and React Native being mentioned, or Vue, Angular, and React all mentioned at the same time. Now, jobs at Stack Overflow is more of a cutting edge. And as I said, multiple technologies can apply per job. So what do we find if we look at, and all of the data that I see today I gathered earlier today, so it's as fresh as can be. So React, by far the most jobs, then 79, Angular, a very distant second, and Vue, about the same number of jobs as Angular. And JSF, Thymeleaf, and Vardin don't exist as far as the Stack Overflow job audience is concerned. Then I looked at a job engine called Indeed. You may not be familiar with it. What's nice to me is that it exists in more than 60 countries. So it's a lot more mainstream. Again, it's a technology being mentioned. It's more primitive. It's just, full text search, and you find all the details on my page. So I had to do some twisting of the data, some adjusting to account for that. Once more, you can have multiple technologies per job. So the same job can show up as a hit for, Angular and React. And these are the 15 countries that I manually searched all technologies through earlier today. So they represent, North America, a good portion of the South American economies, the biggest European economies, and some countries from Asia. Sorry, but I don't read Chinese or Japanese, so I couldn't search jobs there. So Angular and React globally across these 15 countries are virtually tied. Vue.js is about a quarter of these two, and the rest just barely exists. So Angular and React on the global job market, they are the go-to candidates. So let's sum up popularity of our web technologies. React wins, Angular is second, Vue.js is third, and the rest is places 4 through 6. And that's why I'm going to vote these three guys off the island. They're not declarative. Vardin can be, but Thymeleaf, JSF, they are not. So they're not state of the art. They're not popular, as we just saw. And I also think that Thymeleaf and Vardin are not safe. As a single company behind Vardin, will it still be here 5 years from now? Who knows? Thymeleaf is a open source project. Will it still be here 5 years from now? I don't know. So these three are out. And so then there were 3. So now let's apply the wish list that I put together, the 12 criteria, and rate our web technologies. Now, not all of this applies here. So these are our criteria. How do React, Angular, and Vue score here? Angular is, to me, the winner in the Java category because you have to use TypeScript, and TypeScript is closer to Java than plain JavaScript. React is the only declarative framework, so it's the winner here. I think React is the safest of these 3 platforms to still be around 5 years from now. I'm going to be talking about Google and projects in a bit. We saw that overall React is the most popular one. As far as web applications are concerned, the kind of that we want to build, I think they're all doing the trick here. There's not one that pulls ahead. So they all can deliver capable applications. I'm not sure which of them has the best ecosystem. Typically, they all use plugins from or modules, node modules from NPM. So I think that for what we want to do, you can probably find your favorite frameworks for all these three libraries. I think React is probably the fastest. It has some advanced technologies about, simultaneous rendering and deferred loading. You can find details on my talk page, what I'm talking about here. And I haven't worked with React and Vue enough to tell you which of them, is the winner in the build, deploy, and debug category. Now, taking all of that together, probably comes as no surprise that I declare React to be the winner, Angular to be the silver medalist, and the bronze medal goes to Vue. And just a reminder, JSF, Thymeleaf, and Vardin were kicked out. So here's my advice on the web for you. If you have a project, then, and you then keep it if it's React, Angular, or Vue.js. If you use JSF, Thymeleaf, or Vardin, you should contemplate whether you want to migrate that project. Typically, it just doesn't work out. It doesn't make economic sense to rewrite an application just to change the framework, the front-end framework. So I think in most cases, if you investigate, should you migrate to something else, the answer is going to be no. But, still, it may, make sense to look at your options. Now, if you start a new project or you migrate an existing one, then I recommend you should look at React first, then Angular if that doesn't work out, and then Vue.js as your last option. So we've got our first scenario completed. Now let's move on to the second one, talking about mobile. Remember, we wanted to build native applications for iOS and Android. Doing the same thing, what's most popular? Let's start with Google searches, Google search trends to be precise. So here we just start a little bit earlier, so just January 2015, so the last 6 years, if I'm not mistaken, 6 years and change. So Xamarin is the least popular one. It's the green line, just barely, it's essentially flat, 0. JavaFX used to be popular, but it's been declining for the last 4 years, I want to say, since 2017. React Native is the yellow one, was the most popular for a while, but was overtaken by Flutter. Yes, you guessed it. Flutter, just as with the other searches, both Flutter and React Native are declining over the last year. Flutter got a little bit of a bump here. They had the big conference in early March, but now it's, downward again. But still, Flutter wins here. Let's look at the questions at Stack Overflow. So here, also going back to 2009, well, which is when people actually asked about JavaFX. And then, as you can see, JavaFX, the orange line, got a bit of a bump, but been declining for the last couple of years. Xamarin overtook JavaFX briefly, well, still ahead of JavaFX, but also declining. The green line is React Native. We can see it's still growing, kind of stagnating at the moment, and Flutter is the clear winner here, still growing, about half as popular as React. If you recall, React, the web version, had 5% of the question. Flutter is approaching 2.5%. Let's look at courses on Udemy. Here, Flutter is the clear leader, nearly twice as many as React Native. Xamarin has about a third of what Flutter has, and then JavaFX is a distant fourth. If we look at students, the picture is a little bit closer. So React Native is a little bit closer to Flutter. Xamarin actually a lot worse off than Flutter, and JavaFX just hanging in there. Books at Amazon, again, US books, English, computer technology. This is probably the closest you'll see here today. Xamarin actually leads. Looks like Microsofties read lots of books, or at least they pretend to. Jobs on Stack Overflow. Ouch. So no JavaFX, Xamarin and Flutter both tied for second place, but the clear leader is React Native. And now let's look at our 14 countries, I think. And their React Native, is the clear leader. Flutter has about a third. Xamarin has about, a fifth of what React Native has. JavaFX just barely there. Now, the numbers are actually skewed. If you take out France and India, which are both very heavy in Flutter, then the numbers change a bit. With Flutter, it's a bit difficult because, for instance, Flutter is also the name of an online betting company, so that could skew the results here. So without France and without India, the picture is more clearly tilted towards React Native, which has then nearly 5 times as many jobs as Flutter. And that's actually, if you think about it, you can at least come up with reasons. React wins in the web development, and then when you're doing a React project, you're probably going to switch use React Native for your client project. And I think that's what's giving React Native a boost. So that's why I'm declaring React Native to be the most popular one, and then Flutter, Xamarin third, JavaFX fourth. And again, 2 of these guys are out, Xamarin and JavaFX. They're both not declarative. They're both not popular. And at least JavaFX is not safe. Xamarin is. It's Microsoft, so they're going to give us a migration path. And so that means we just have 2 options left. So let's talk about my Flutter experience on mobile. I used it on a project. And first, let's actually define what Flutter is. Now let Google do the talking here. So let me highlight the most important parts. So Google wants to build beautiful, natively compiled applications for mobile, web, and desktop from a single code base. Got their work cut out for them. If we compare React Native and Flutter, React Native uses JavaScript. Flutter uses Dart. More on that in a moment. React Native has slower rendering because everything runs through a JavaScript bridge. Flutter is faster. It uses the Skia rendering engine that also Firefox and Chrome use for rendering. React Native uses the native SDK, so you see real iOS and Android widgets on the screen. Flutter emulates them, and that leads to trouble. React Native unofficially supports Windows and macOS, not officially, but Microsoft gives you support for these 2 operating systems. Flutter officially supports Windows, Mac, and Linux. And then when it comes to building a project, you actually have 2 different ones in the React world. You've got your React Web app and your React Native app. Flutter has just 1 code base. I talked about Dart here, and as Java developers, you may ask yourself, well, why do we have to learn another language? Can't we just write, Java? Because in the end, all we want to do is write code like this. Now, what if I tell you that this code is actually Dart? It's Dart, it compiles. It kind of looks like Java code. It doesn't compile in Java. There's one place where you could have seen it. Yep, in Java, of course, list is an interface, and you need to use a real class to instantiate. It's a class in Dart. So what is Dart? Well, Dart was originally built for the browser by Google, but then it was repurposed into a simplified Java for UI. So what do I mean with simplified? You just have public and private for visibility. You have less data types. Everything is an object, but you also have some tweaking specifically for UI building. And on my talk page, you can find the link where Dart, Java, and C# are compared. I recommend if you're into finding out how that simplification works. Dart is, during development, it runs in a virtual machine, but when you deploy it, it's natively compiled, which means C++ code and machine code on native platforms. If that rings a bell, yes, that's exactly what GraalVM does, which is the hype these days. Everybody wants to use GraalVM. That's what Dart is doing to VM during development, natively compiled for deployment. Fast build and deploy is especially important on mobile. Why? Well, mobile builds are slow. It's not uncommon for Xcode to churn a couple of minutes before it puts the app on your iPhone. Now, Flutter has 2 tools to combat that issue, 2 weapons in its arsenal. The first one is hot reload, which applies changes pretty much immediately. And then hot restart. Hot restart puts your app back, but it also just takes 2 or 3 seconds, and your changes are there, and you can start anew. And this is faster than native development. And so let me show you. Well, so what do we just see? We saw that hot reload is really fun and it keeps the flow because your changes immediately become visible. It works in emulator, it works on a device, and it really keeps the flow. So no more waiting, for half a minute and checking Twitter or, Facebook for some news. You make your change and the change immediately is live. There's also dev tools. I just barely started to use them. They can help with tuning your app. They actually build as a Flutter web app. So that's what they look like. They run in the browser. You can see the, your UI and how it looks like. On the left side, you've got the hot reload and hot restart buttons at the top, and you've got some more tools here that help you, achieving this, beautiful, fast applications that Flutter wants you to build. Flutter has plugins, about 15,000. Not all of them work on the web or so, mobile platforms yet. Most of them are open source. There's a great portal, and you can find some screenshots there in the talk page. And what I especially like, if you have a problem with one of these plugins, you can just fork it. They're all pretty much on GitHub. And then you put in your fork URL into the build file. So without publishing anything to a portal, you can use a forked version of a plugin. Pretty great. So how does Flutter run? You can build standalone apps and put them into the App Store, but you can also take an existing native app and just add screens to it, build just these screens with Flutter. Talking about native apps, how do you integrate with the native platform? How do you get access to, the camera or files? Through plugins. So for most of the things that you need, camera, files, picture gallery, network stuff, you get plugins that do the work for you. You can also integrate native screens. That's, for instance, how you get Google Maps on the in Flutter. It shows you either the iOS or Android native screens. And if all of that is not enough, for instance, you want to do geofencing or do some stuff with the native code, there are channels which are publish and subscribe channels, or you have a C API. So to sum up what's good about Flutter, Dart is a simplified Java for UI, especially tuned for UI building. You get fast code build and deploy. Plugins save us time, and the native integration is simple. So what issues do I have with Flutter? You're going to hear all about it now. First one is it's a Google project. So everybody and their aunt is going to ask you, when will Google kill Flutter? There are whole web pages dedicated to projects killed by Flutter, such as Google Chrome apps or AngularJS or Google Hangout. And of course, the answer is we don't know, right? We don't know whether Google is gonna kill Flutter. What's bad is that Flutter has in-house competition. Angular is for web and mobile. We've got Jetpack Compose, which is Flutter for Android. So that's not good. 3 projects all vying for Google's attention. Now, what's somewhat good, I suppose, is that Flutter is the user interface for Fuchsia, the mysterious Google operating system. And Flutter is actually quite popular. Toyota recently announced they're going to use it for in-car entertainment systems, and Canonical will make Flutter the default way to build applications for Ubuntu Linux. Now, for the next point, I need to show you that there's 3 ways you can build designs with Flutter. Number 1 is you can bring your own design, like Netflix does. No matter where you go, Netflix always looks like Netflix. The second way to build your app is to use Google's material design. Looks like that, used by all the Google apps. So that's the second way that you can build with Flutter. The material design library is part of Flutter. And the third one is the native design. You want to build an application that looks like Windows File Explorer, for instance, right? So the question is, can you really build mobile web desktop with one code base and with Flutter? Heartbreaking. The answer is no. So why not? On the desktop, Flutter is just in preview mode. So it's not ready for production yet. There are no native libraries. You can't build a Flutter app that looks like an a Windows or Mac application. What you have to do is to customize the material widget set. That's the official recommendation. On the web, Flutter Web just recently became 1.0 in early March. And again, you can't build something that looks like Bootstrap or something. You have to customize material. That's the only way. So, and then 15,000 plugins sound quite nice, but if you compete against NPM, you've got hundreds of thousands of modules there. So this is my app in portrait mode and in landscape mode. You see the two cards on top of each other and right next to each other, right? Quite common because you rotate your phone or you've got big devices. Flutter doesn't really give you a good way of doing that. And so I used a plugin that imports the Bootstrap grid, the concept of the Bootstrap grid into Flutter. Native design for mobile. So also not all components are there. For iOS, for instance, there is no table view. So you use some plugins that implement the table view, but I think it should be part of the stack. It's time consuming to build an application that both looks native on Android, which is Material, on iOS, where you have the iOS widgets. And so in the end, you build your own components there. Could also look at the Flutter team and think they're overwhelmed. There's lots of issues there on GitHub, you can see, and there are some long-standing trouble things, such as janky animations. That's what it's called, janky animations on iOS. Now they've got their handfuls because they just launched web and they're busy on working 3 desktop platforms into their system. They also had a feature called null safety. That means pretty much all the plugins need to update. You can find more about that on my talk page. But the good news is they hired some external developers to take care of some of their own plugins. The Firebase plugins, you may have heard of it. It's a Google system. They outsourced that because they just didn't have the time to do that. So to sum up, what's bad about Flutter? Everybody and their mother is going to ask you, will Google kill Flutter? You can't build all the applications with one code base. Responsive design is hard, as is building mobile native designs. And you could look at it and say the Flutter team is overwhelmed. Now let's look at our wish list for mobile, the 12 criteria. How do React and Flutter compete here? Well, for Java, it's no contest. Flutter wins because Dart really is a simplified Java. They're both declarative, so no winner here. I think React is safer, React Native. React is also more popular. React as a web platform is more mature than what Flutter has. Now for mobile, I think they're good enough for the kind of applications we want to build. On the desktop, I would say it's a draw. Yes, Flutter has 3 platforms officially supported, but no native design. You can get native design on React Native, but they're unofficially just supported by Microsoft. I'm not sure which of them has a better ecosystem. I think Flutter is a little faster because of the rendering, the native rendering with the Skia engine. You can also get easier access to native functionality with Flutter. Only with Flutter, you get one code base. And I don't know who's actually, faster in build, deploy, and debug. I think React Native also has something like hot reload. So who's the winner? I declare Flutter to be the winner and React Native the second place. JavaFX and Xamarin, I voted them out. Now, this is one place, remember at the beginning where I said, you have to pick your own criteria. this is one place where you could disagree with me. For instance, you could say, well, React Native is the winner, clearly, because all the jobs are with React Native and the drive from React is with React Native as well. You know, React wins and there are more jobs out there. That's why I said you need to apply your criteria. I picked Flutter because I'm my own boss in my startup. And so I liked what Flutter gave me. You know, maybe different for you if you try to sell your teammates or your boss on Flutter because they just look at the number of jobs and say, are you mad? Of course, we're going to go with React Native. So here's my advice for mobile. If you have an existing project with Flutter and React Native, then keep it. They're both fine frameworks. If you have JavaFX, think about migration. Again, mostly doesn't make economic sense to do the migration, but at least, you know, consider it. And with Xamarin, you have to wait for Maui, the multi-platform app UI. And yes, Maui is also an island in Hawaii. So wait until the end of the year. If you do a new project or you migrate indeed, then if you use React, then you go for React Native first and then for Flutter. If you don't use React, then you go for Flutter first and then for React Native. And again, with Xamarin, you have to wait for Maui at the end of November. And so we're done with mobile. And you say, Jesus, we're already 2 minutes over and we still have to talk about desktop. Well, good news, desktop is going to be a short section. And the reason is there is just no good option on the desktop right now for cross-platform. Why? There's lots of change. With Windows, they have this new design language called Fluent Design. And you may have heard there's Windows X, you know, for these devices that have multiple screens. So, you know, lots of change there on the iOS side, on the Apple side. Apple just introduced a new design language in Big Sur, the latest macOS version. And desktop has always been difficult and expensive to support. You know, you had installers, you had people mocking with your applications, you had virus and malware and all of that stuff. And the biggest issue here is that the web is just good enough. You know, all your customers, they use enterprise applications in their web browser day in, day out, which is why I say keep your web application, use it on the desktop. Only if you build your own design, or if you're happy with material design and you also use Flutter, then you can evaluate Flutter for desktop. Again, probably just next year, it could go into production because it just entered preview or beta. And now we're done. Do I follow my own advice? I told you about the project that I'm working on. And yes, for web, I use Angular, but I'm in the process of learning React. And I hope just to do React projects in the future. For mobile, I build with Flutter. And on the desktop, I use my Angular web application. So to sum everything up again, I gave you advice in 3 different areas. First one on the web, I hope you still remember it. So for your existing projects, keep React, Angular, and Vue. For JSF, Thymeleaf, and Varden, consider migration. Migrations rarely do make sense economically, but still consider it. If you start a new project or you do migrate indeed, then use React, Angular, or Vue in that order. For mobile, we're just talking about it, keep Flutter or React Native. And for JavaFX, contemplate a migration. Xamarin, if you use that, wait for Maui in November. And if you start a new project or you actually still a German word in there, Umstieg, which is migration, didn't update my slide. Then if you have React, start with, if you're using React for your web project, use React Native, and then Flutter. If that doesn't pan out the other way for everybody else, use Flutter as your first option and then React Native. And for Xamarin, you know, the jury's still out, got to wait for November. My advice for desktop was keep your web application, and only if you use material design and Flutter, then you can evaluate Flutter for desktop next year. And that marks nearly the end of it because I have a little announcement. I'm looking for a project starting October. So if you're looking for a contractor or a fixed term employee, Milton Keynes, London, or remote, I can be your guy. So here, I want to promote one last time my talk page. You can find the slides and the video, extra information that I kept referencing throughout the talk. You can give me feedback. find links to get started with React and Flutter, and you can subscribe to my newsletter all at this URL. That's also in the Meetup abstract. And I'm done.
Okay, thank you very much, Karsten. It was really interesting and helpful, hopefully, for our viewers. Now, we have 3 questions in our channel so far. And I'll start with the first one from Ben. And he asks, how is Angular not declarative?
The reason why I would say that Angular is not declarative is because you typically, like most people, you use templates. And so your code and your UI can be at least in a separate file. And that's why I want to say it's not declarative. I guess you could do like inline styling and inline HTML, so to have all the things that you need typically in 3 different files in one file. And then you maybe could consider it to be declarative. And I think in contrast to that, React has a stronger push to have everything, in code and have the UI side in line with the code. But I suppose, yes, you could probably write declarative with Angular if you cram everything into your TypeScript file. So let go of your HTML and the CSS, and I think then, yes, it could also be considered declarative.
Cool. I hope this answers the question. Then Reinhardt asks, what about using plain ES6 web components? Have you considered that?
I have not considered that. I typically go for these frameworks. I think that's it's an option, but what I'm not so sure about is about everything around it. What about state management? What about routing? Those are typically the issues that you're dealing with. I mean, components is one thing, but there's more to an application than just component. For instance, in React, I think there is no default router. You got to pick one, and state management is also something that you got to pick, which is also a hot button issue on Flutter. So I have not considered it, but maybe next time, next version of my talk.
Okay, thanks. Then Gunnardi asks, there is another web framework, so-called Svelte. Compare with the web framework mentioned in the presentation. This framework doesn't use virtual DOM, which makes it more simple and faster than React. Do you consider it?
I have not considered it. When I gave the talk the first time, I just had 3 frameworks in there, and now I've got 6 of them in there. So maybe I can consider Svelte and put it in the future. I have not looked into Svelte. Especially on the web, there's a gazillion framework and there's new ones coming out every day. But maybe I should drop one of the other ones that I have in there, like ThymeLeaf, because it's not very popular, and instead use something like Svelte. So thank you for the suggestion.
Cool. And Brian asks for a recommendation. Any good books to get started with React for a Java dev? Can you recommend?
I've got on my website, on the talk page, the URL which you see above, I've got links for courses in both React and Flutter. My 2 recommendations, Udemy courses, free courses, courses on free Codecamp. I just have courses there, not really books. I often find books to be pretty quickly outdated. I mean, Flutter has like a new version every 3 months. React, I think, also moves pretty quickly. So some of the courses I put there, they get updated regularly, at least once a year to deal up. So if you come across a book, then I would try to find a book that gets regularly updated, because things change a lot. For instance, in Flutter, we've got null safety, and that changes a whole lot how you write code. So if your book is from last year, then it's already outdated. You can't use it. So if you look for courses or books or whatever material, try to find something that's up to date and also keeps getting updated.
Okay, then Nikolai Karajov says that you can build desktop apps with JavaScript, TypeScript through Electron. Have you tried that?
No, I have not tried it. I know it's a popular option. Slack, for instance, is built like that, and I think Visual Studio Code is built like that as well. But I was looking I was looking for a cross-platform. yeah, so I have not considered it because I want to start with one code base, because so something that I can use to build, web, mobile, and desktop from one code base. And so to me, it seems like these Electron apps are more of an offspring of a web application. So you just have a regular web application, and then you would just change that to build on desktop. So it didn't fit my one code base approach here. Because it seems to be, I think it's just a different way of building something just exclusively for desktop. So for me, it would be fitting more into the categories of, a native framework, because you're building for, 2 platforms, but it's not something which also works on mobile or on the plain web. But maybe I'm wrong there.
Okay, then Tim asks, he says, I've been learning Swift UI. And since you shared it, I'm curious how you think it fits into the decision metric. And he guesses Apple only, Swift UI wins.
I think that, it's a native framework that you can use to build apps for really iOS. I don't think many people are building macOS. So I think it's a fine option to use. To me, it's really just that if you want to support mobile, you also have to put something out for Android, right? So if you if you have Swift UI, then you immediately have to use something else for Android. That's the one thing. The other thing is Swift UI is still pretty new. Doesn't have all the features, and especially device support. You have to be on the latest version of iOS. So for somebody like me, that's not an option, right? I need to support old devices, and that's where React Native and Flutter shine. They go back 6 years. So I think with Flutter, really realistically, you can use iOS 10, which is nearly 5 years old. And with Android, you can also support 5-6 years back of Android version. So that's really an advantage, because lots of people don't have the latest phone. The Swift UI, my impression, you pretty much have to use the latest version of iOS only. Now, in the iOS ecosystem, people upgrade quite quickly, but again, even if you get the iOS platform covered, what do you do on Android, right? You immediately have a second platform. That's why I think in many cases, something like React Native or Flutter can make sense, because it's a single platform, a single application for both platforms.
Okay, thank you. And the last question for tonight is from Imre, and it's a really short question. JavaScript versus TypeScript.
I prefer TypeScript because TypeScript makes JavaScript more like Java, just starting with what gave it its name, type. You can have types, you can have interfaces. They still put the type after the variable. It's barbaric, but that's the same in JavaScript. But yeah, TypeScript, no contest.
Okay, then I think that's all for tonight, or for today if you are watching in the Western hemisphere. So thank you very much for joining, and Karsten, thank you so much for presenting and for speaking to our community. And yeah, maybe see you again later.
I'd love to come back.
Okay.
Well, thank you. Thanks for your attention and for your time, and you have a great day. Bye.